Okay, moving on to the second part of Unit 1. What I what we ended up doing at the end of the last slides is discussing in broad terms what science is. But I'd like to give you a few more definitions that are important for understanding what science is and what it means. So the first thing that I want to point out is that science is empirical. Remember what the word empirical means. It means it's based on experience. And so, in order to be science, what you have to rely upon is observable data. So, things that you're able to measure. If you're not able to measure it, if you're not able to perceive it, you can't use science as a means to resolve it. So, for instance, there's a saying, how many angels can dance on the head of a pin? Um, we can't observe angels, so we can't do a project that is trying to aim towards understanding how many angels can dance on the head of a pin. Similarly, uh, people have always wanted to prove the existence of God, but God is not an observable entity, and therefore one cannot do science on the existence of God, although one can clearly do science on the effect of religion on psychological well-being and behavior, but there are certain things that are outside the realm of observable things, ghosts, spirits. These are things that science really can't address because they're not observable. Science also is objective in the sense that you need to have data on things that can be measured accurately without bias. If it's the case that your measurements are influenced by bias of some kind, then you're not going to come up with accurate conclusions because your observations themselves are not empirical. They are based on previous notions, or they're based on some kind of a skewed perspective that will lead to incorrect conclusions. Third, science is self-correcting. And this goes back to the importance of replication, the idea that if you do a study multiple times, that you're going to come up with the same answer. And in a sense, it's the case, and we're going to be talking a great deal about this idea of self-correcting and about replication. But in a sense, if you do a study, it's often the case that someone else is interested in what you have done, and they want to try to do the same thing. And so that's one of the reasons why when we write up results in journal articles, we tell people exactly what we did so that if they're interested in doing the same thing, they can do it. And if they do it, they either will find the same result or they will not find the same result. And that's the difference between replicating and not replicating a finding. But it's the hope that in the long run of science, that this process of self-correcting over and over again leads to, because it allows for a reassessment of conclusions, leads to more accurate conclusions about the world than if it were not self-correcting. So this idea of replication plays a very important role in moving science forward and allowing it to, correct itself. Science is progressive, and this is a related idea, that knowledge really builds upon earlier conclusions. So it's not as if you go out there and you come up with a project out of the blue that has no history in other people's thoughts. You have to understand that people have been doing psychology since the mid 1800s. So there's 150 years or more of research out there on all sorts of things that people have imagined having to do with psychology. So what your first step to do when you're doing science is to find out what other people did before you, because it is probably not the case that you're the first person on earth to think of a particular project. And what you do in finding these earlier conclusions is that you realize that, what they did before wasn't really the best way of doing it. I have a better way of studying this phenomena. And then you progress on what people did before you. I think it was Newton that famously said that, we see further because we stand on the shoulders of giants. The idea being that you can see further on this wall of knowledge because you're standing upon all the other contributions that other people have already brought to the table. And that's an important feature of science. Science is also tentative. The only absolute truth is that there are no absolute truths. Science is tentative in that conclusions can be based on data that was incorrectly calculated, incorrectly collected. There are lots of ways in which science can be wrong, and so it's important to understand that any study that's done on something is not the final word. If you ever read in the newspaper that some new research study shows that, say, eating hot pepper reduces heart attack risk, what you need to understand is that that finding itself is tentative. It's not proven to be true. And if by the end of this course, one thing I want you to learn is that no science proves anything to be true. It only provides evidence that's in favor of one particular claim over another. But always science is tentative, and be very careful. If someone's trying to sell you something and saying that, this science proves this to be good or proves this to be bad, understand that science doesn't necessarily do that at all, and that all science should be viewed as a tentative step towards a more accurate conclusion. So some fundamental assumptions of science is that the world is real. Now here I have a picture from the movie The Matrix, which came out a good 20 years ago. And the idea behind this movie was, if you haven't seen it, this notion that our perceptions of the world outside of us are really that we're embedded within a computer matrix that feeds us our perceptions. And in reality, part of the plot of the movie is that there are some beings that are harvesting our energy. I don't want to go into the whole plot of this movie, but the idea behind this is that the world really isn't real. The reason why I put this here is that you have to reject that if you want to be be a scientist. You have to assume that the world is real and that there are phenomena out there that are worth studying. But there are people that truly believe in this. It's a philosophy that's called radical skepticism that argues that we have no way of knowing that the world is real. But that's a view that some philosophers have taken. If you're a psychologist, you really have to understand that the world is very much real and the phenomena in it are very much worth studying. So in this slide, I just have this idea. Psychologists should be realists that believe that objects exist outside the mind, and that there's this other view, the radical skepticism, that argues that our knowledge is based on sensory data, and because our ability to perceive the world is flawed, there's no way for knowing for sure that the external world exists. This goes back to a guy named George Berkeley, who was a philosopher in the 18th century who came up with a series of arguments in favor of this claim. Now, I'm arguing that psychologists shouldn't be radical skeptics, but an important question might not be whether the world is real, but how different people interpret the same world in different ways. And that might be a very important insight for psychologists to look into. Now, a second assumption is rationality, and I often illustrate this using the Mueller-Lyer illusion. The idea here is that when you look at this, you see two lines that look like they vary in length. Now, you can't, as we talked about just a second ago, we're assuming that the world is real, but there are some aspects of the world that make us misperceive the world, and so we need to use rationality as a way to be able to determine what is right from what is wrong. And one way in which you can do this is once you remove those little ends, you can see that the phenomena of the one line being longer than the other goes away, and they look to be the same length. And the idea here is that one can use a rational approach to be able to solve this. All you need to do is measure and not necessarily trust your direct perception. And that's something that psychologists have to do all the time, is use rationality over perception. So rationality is arguing that the reasoning is the basis for solving problems because the world is understandable through observation and logic, and that truth is obtained through reason, not through perception. And those are important insights. Another assumption is regularity. The idea here is that observable phenomena exhibit consistent recurring patterns that conform to universal laws. So a law is, of course, a statement that certain events are regularly associated with one another in an orderly way. So, as I said earlier, if I throw a ball up in the air, it's going to eventually fall back to the earth because what goes up must come down. It's the law of gravity. Other laws are, um, that if I show you the two lines with the arrows pointing the opposite direction, that you will see that line as being the one line being longer than the other line. That's kind of a law of perception. And so these are things that have to do with the idea of regularity, that um, phenomena occur in a regular way. The opposite of that would be chaos theory, where things occur based on random events, chance, and therefore they're not predictable. So, for instance, flipping a coin. I don't know enough about the physics of how coins move in the air to be able to predict, given a particular toss, what is going to come out. And so that is chaos. And so that's outside of the ability for science to understand regularity. And so assumption of science is that the phenomena that you're studying are regular. Now, I have to say that studying things that are not regular, studying coin tosses and things like that, that's a very important part of statistics, but only in that it makes a demonstration of the difference between regularity and chaos. And so I use the example of coin tossing because it'll come up later on when we talk about statistics, because statistics is about regularity, and the reverse of regularity is chaos or randomness, and that's what coin flipping or card drawing, things like that, represent. Next, discoverability. Um, Again, this goes back to the idea that science is empirical, that it should be possible to solve scientific problems based on observation. Okay? And the philosophy that underlies this is called positivism, that the world is knowable through empirical observation, which goes back to a philosopher named Karl Popper. But the idea is that scientific problems should be discoverable. Okay? They should be based on observation, and if they're not, if they're dealing with phenomena that are outside that which is discoverable, then we're dealing with other kinds of issues like philosophy. So, for instance, a philosopher might ask questions that aren't discoverable because you can't base it on observation. For instance, what if we met and, here's an example that I use from a book I recently read. What happens if we were to have a machine that would take us atom for atom and replicate us on a different planet like Mars? Okay, and every atom was maintained. What would our identity be like in our old body and our new body? Now, that's something that is in a book that has to do with some philosophical issues that are kind of complex, but that's not something that a psychologist can deal with because we can't observe that. We don't have a machine that can do that. So, as much as it's an interesting thought experiment, psychology doesn't deal with thought experiments. It deals with discoverable phenomena. And that is the difference, really, between philosophy and psychology. And so I think that's an important thing to just keep in your mind, is that psychologists must study things that are discoverable. If they're not discoverable, it ends up just being a thought experiment. And the problem with thought experiments is that, with enough argument, you can almost make any claim to be valid. Next, causality. Causality is the idea that all phenomena occur for a reason. So if I throw a ball up in the air, it goes up in the air because I put acceleration onto it. There was momentum, it left my hand, and then it loses that over the course of time, and the kinetic energy in it becomes potential energy when it reaches the peak of its arc, and then that begins to fall again and ends up being kinetic energy. But there's causality in all of this, that, gravity is the force that acts upon things and what causes it to fall. And determinism is the doctrine that all events occur because of a preceding cause. And this is kind of an important idea, because is it the case that phenomena happen at random, or are there predictability? Is there some kind of a law that we can establish? So some examples might be lung cancer is caused by tobacco use. So its excessive use of tobacco is the thing that comes before the lung cancer, not that the lung cancer causes the tobacco use, or that people become depressed because of atypical brain chemistry, or aggression is caused by poor parenting. It's not the case that the poor parenting came after the aggression, and that's the idea of causality, is that the cause must come, before the outcome. And this is kind of opposed to fatalism, which argues that everything happens because of a plan. So if someone says to you that the universe is ordered in such a way that it was just her time to die, or it was his moment to be in the spotlight, that's more of a fatalist argument that sort of ignores the fact that most consequences, are the result of a particular cause. And psychology really aims to understand some of these causes. Now, the problem, though, is that it's often difficult to come up with the true cause for a phenomena. And one of the examples that we're going to be using later on in this class is the relationship between the amount of ice cream that's sold and crime. Okay, because there's actually a very strong relationship between the amount of ice cream that's sold in the United States and the crime rate on a month-by-month basis. And the idea here is, as ice cream sales go up, crime rates go up. So the idea that, most people might assume is that there has to be some kind of causal relationship between the ice cream sales and the crime rate, so that one causes the other. But this is a fundamental flaw in reasoning that is classic in psychology, which is to mistake correlation with causation. Okay? Because just because two things are correlated doesn't mean that one is the cause of the other, because there always can be a third factor, namely temperature, that's driving the increase in ice cream sales and the increase in the crime rate. So it's not that the ice cream causes the crime rate, but that some third variable that you may not have studied causes that relationship. And this comes back to actually a very fundamental issue in psychology that we're going to be dealing with throughout this course: the difference between what's called an experiment and a quasi-experiment. Okay, and it becomes very hard. A true experiment might, if you're looking at does smoking cause lung cancer, if I were to do a true experiment, I'd take 100 people, and 50 of them, I would say, you smoke for 25 years. And for the other half, I would say, don't smoke. And compare at the end of 25 years which group had a higher rate of lung cancer. Now, you can't do that study because it's unethical to force people to smoke who don't want to smoke. So you can't do true experiments in that way. Now, of course, you can do such experiments on rats and have one group of rats that are breathing in tobacco smoke and another group that are not. But with humans, there are certain things that you just can't do as an experiment, where you randomly assign people to different groups. And so you have to deal with the fact that the people in the group define themselves as either smokers or non-smokers. And those two groups might differ in a variety of ways that are not just their behavior of smoking. It may be the one group is poorer than the other, or the one group lives in neighborhoods where there's more pollution. So that's the problem with causality, is that it's very hard to get at the cause of a phenomenon. And that ends up being a very important thing for psychologists. Now, parsimony we mentioned before, which is the idea that a simple explanation is usually one that's favored over complex ones. There's something known as a Rube Goldberg machine, which is this huge machine that does a very simple thing. So he was a cartoonist that would design these cartoon drawings of machines where to break an egg into a frying pan would require the machinations of 15 different steps of things going on, like a balloon popping and a ball rolling down a chute. And I use that as a metaphor for a complex explanation. That's not the easiest way to fry an egg. The easiest way is to break an egg into a pan and not have to deal with a huge machine that does it. So, in reality, in psychology, we tend to favor those simpler explanations than more complex ones. Now, finally, in the last few seconds here, I just want to say what are some characteristics of good scientists. Good scientists tend to be enthusiastic. They love what they study. They've made it their life to study this phenomenon. And, science is, a good thing to go into, but most scientists don't end up being very wealthy from the science they do. It's more of a labor of love that they do because they're enthusiastic about the research that they're working on. Secondly, they tend to be open-minded. If you have a closed mind, it's very hard to come up with new ideas or to think outside the box. So therefore, good scientists tend to be a little bit more open-minded than closed-minded. Third, scientists tend to have common sense. It's just an important ability to be able to understand the way in which different phenomena in the world are related to each other through good common sense. And so that's a feature of personality that I think is really important in scientists. Perspective taking. It's very important if you're someone that does experiments on people to be able to take the perspective of the person who you're studying. And so being able to understand, for instance, that a 14-year-old child doesn't want to answer a 150-question test of self-esteem, you need to be able to understand what the mind of a 15-year-old is like. And so being able to take perspective is really important. Creativity is important as well. And what you find is that some of the scientists that you meet are some of the most creative people that you'll ever encounter, because there really is an art to science, and there's an aesthetic to science. Coming up with a beautiful, elegant study is really something of an experience of wonder. When you see a beautiful study, you just can stare at it just like you could stare at a beautiful painting and be like, wow, this is amazingly creative. And that's when you know a good study, is when you have that response. Scientists are also pretty confident in their judgments. If you're not confident, you're going to have a hard time writing a paper, making an argument about something that you've studied. So being confident is really important for being a good scientist. Communication ability, whether it be giving talks at conferences or writing papers that other people are going to read. The ability to communicate is central. And it's one of those things that, whether or not you're a scientist or not, the ability to communicate has a really important role in life in general. So this is where, in college, you really should be working on improving your ability to communicate, improving your writing, eliminating errors in your grammar and your spelling, because the first way in which people will know that you have shoddy thinking and sloppy thinking is sloppy writing. So improving your ability to communicate is really important on the road to being a good scientist. Of course, caring about details is very important. Science can be a very arduous task with many different things to have to deal with. There are, in certain data files, thousands of variables that, if you take the wrong variable and analyze it, you're going to come up with the wrong conclusion. So being attentive to details is a really important characteristic of scientists. And finally, integrity. Integrity is one of the most important things that a scientist could have. And the idea here is that your reputation as a scientist is based on your ability to honestly be able to face the results that you come up with. Sometimes the results that you produce are not ones that you expected, and in fact are ones that you didn't want. But you have to deal with this. You have to accept this. And we're going to be watching a video about a astronomer from centuries ago who, faced with data that went against his conclusions, got very frustrated, but ultimately he came up with the correct results because he refused to let go of the data and had high integrity, and I think that's something that scientists really need to have. Finally, good science, it tends to have what we call methodological pluralism. The idea here is that there's more than one way to skin a cat. If you do a study one way and then you do it in a different way and you come up with the same result or similar results, that means that the phenomena that you study is probably pretty solid and you're looking good. And that's an important thing. Theoretical ecumenicism. This idea is that there's more than one reason to do a study, and so if you have greater motivation based on theory to study a phenomenon, that ends up being a really important thing to be able to improve upon your science. The aesthetics. Good research is, it's beautiful. It's aesthetic. And I think that that's something that, you realize over time, is that the best research studies are those which are, that are both scientifically solid, but also beautiful in and of themselves. And I think that's something that we'll realize as we read more and more research. Perceptible. Okay, so good science, you're able to perceive what your theory is and what your results are. I sometimes call this the grandmother phenomenon. If you're able to go and explain to your grandmother what your science is about, and your grandmother says, "Oh, that's interesting, I get it," that's pretty good. That means that you're able to communicate your study to someone who probably has very little training in the area that you're studying, and that's a good thing. If you have a hard time doing that, you have to wonder how perceptible your results are. And finally, rhetorical justification. People really should know what you do. It's a really important step in science, is to be able to communicate to other people what it is that you're doing in order to justify why it is that we have science in the first place. So that's an important stage as well.